Our solar system hides a cosmic catalogue of the deeply strange. We know the planets, but past them lies a neighborhood teeming with bizarre discoveries that upend everything we think we understand. By the end of this journey, you will see our celestial backyard not as a static map, but as a living museum of mysteries. What causes a perfect hexagon of storms to rage on Saturn for decades? Could there be a hidden, massive planet warping the edge of everything? We are about to explore 25 of the most peculiar finds, from volcanic moons to diamond rain. Which of these cosmic secrets makes you question reality the most? The first entry in our catalogue of cosmic oddities is not an object but a shape. At the very top of Saturn, a storm rages in a form so precise it looks manufactured. A perfect colossal hexagon, wider than two Earths side by side, spins with unwavering discipline around the planet's north pole. This is not a fleeting cloud pattern. It has been there for decades, perhaps centuries, a permanent geometric tattoo etched into the atmosphere of a gas giant. The Voyager probes glimpsed it in the 1980s, and decades later, the Cassini spacecraft stared into its heart, sending back images of a six-sided vortex with walls of cloud taller than any skyscraper, rotating in a slow cosmic waltz. How does nature, with all its chaos, produce something so unnervingly perfect and stable? The leading theories plunge us into the strange physics of fluids on a planetary scale. One idea suggests it is a standing wave pattern, a kind of permanent atmospheric ripple created by differences in wind speeds at various latitudes. Another points to complex fluid dynamics, where the spinning planet and its jet streams interact to self-organize into this polygonal shape, much like the hexagonal cells you can see forming in a simple laboratory experiment with a spinning fluid. Yet, translating a tabletop model to a storm the size of a planet is no simple feat. This hexagon is more than a weather pattern. It is a monument to the hidden rules that govern alien skies, a stark reminder that the familiar physics of our own world can twist into breathtakingly unfamiliar forms in the vast laboratory of space. While Saturn's hexagon is a monument to atmospheric geometry, its largest moon harbors a landscape that feels hauntingly familiar yet profoundly alien. Titan is a world shrouded in a thick, orange haze, a place where the chemistry of life takes a dramatically different turn. Here, the temperature plunges to nearly 300 degrees below 0 Fahrenheit, cold enough to turn what we think of as natural gas into flowing rivers and deep lakes. The Cassini spacecraft, along with its Huygens lander, unveiled this stunning reality. Titan is the only place beyond Earth we have found with stable bodies of liquid resting on its surface. But you would not want to swim in them. These are not water. They are vast seas and sprawling lakes of liquid methane and ethane, hydrocarbons that are gases here on our warm, blue planet. This creates an entire alien hydrological cycle. Methane evaporates from these dark, mirror-smooth lakes, rises into the thick atmosphere, forms clouds, and falls back down as a slow, chilling rain of liquid natural gas, carving river valleys and smoothing hills in a process that looks exactly like Earth's water cycle, but built from entirely different ingredients. It is a landscape of icy mountains and dunes made not of sand, but of organic particles that rain from the sky, a world both eerily recognizable and utterly strange. And within that strangeness lies a tantalizing possibility for astrobiology. While Titan is far too cold for liquid water, its complex brew of organic molecules, bathed in that methane and ethane solvent, could be capable of a chemistry we do not yet understand, a pathway to life that does not rely on water at all. It is the concept of a second genesis, a biology built from a completely different foundation. To dive deeper into this mystery, NASA is planning to send a robotic explorer named Dragonfly. This is not a rover, it is a nuclear-powered drone designed to fly through Titan's thick atmosphere, hopping from one site of interest to another, sampling the complex organic chemistry on the surface. Its mission is to search for the chemical building blocks that could lead to life, exploring this frozen, hydrocarbon-rich world in a way we never have before. Titan is more than just a moon. It is a testbed for the very principles of life itself, asking us one profound question. If life can emerge here in a landscape of liquid methane under an orange sky, then what other impossible worlds might also be alive? Titan's frozen landscape of methane rivers hints at alien possibilities, but another of Saturn's moons presents an even more direct invitation. Enceladus is a small, gleaming world of pure white ice, barely 300 miles across, looking like a perfect frozen marble. For years, astronomers saw it as just another inert, cratered moon, a quiet neighbor in Saturn's vast family. That assumption shattered when the Cassini spacecraft made a startling observation. From the moon's south pole, gigantic plumes of water ice were erupting hundreds of miles into space, creating a shimmering halo around Enceladus and even contributing material to one of Saturn's famous rings. This was not a dead world. It was a world crying out, venting its secrets directly into the void for anyone to sample. Cassini did not just photograph these geysers. It flew right through them, its instruments tasting the spray. The analysis was breathtaking. The plumes were not just water vapor. They contained simple organic molecules, the carbon-based building blocks necessary for life as we know it. More critically, they were salty, and they carried tiny particles of silica, a mineral that on Earth only forms in very specific conditions. That silica was the final, crucial clue. The only way to create particles of that size and shape, scientists concluded, was through the interaction of hot water with rock on the ocean floor. The picture became stunningly clear. Beneath that thick shell of ice, Enceladus hides a global, warm, salty ocean. And at the bottom of that alien sea, hydrothermal vents are likely spewing mineral-rich fluids into the dark water, just like the vents found in the deepest trenches of Earth's oceans. Here on our planet, such sunless, scalding vents are oases of life, supporting entire ecosystems of bizarre creatures that thrive on chemical energy rather than sunlight. Enceladus now offers all the same ingredients: a liquid water ocean, organic material, and a chemical energy source. It has moved from a footnote to one of the most promising places in our entire solar system to search for life. We do not need to land or drill. The moon is delivering samples of its hidden ocean, free of charge, straight into space. The question hanging in those icy plumes is no longer if such environments can exist, but what might already be swimming in the eternal darkness beneath the ice. Europa presents a different kind of frozen mystery. While Enceladus actively sprays its ocean into space, Jupiter's moon Europa keeps its secrets locked beneath a global shell of ice. From a distance, it looks like a cracked marble, a web of dark lines crisscrossing its brilliant white surface, resembling the fractured shell of a cosmic egg. These cracks are the first clue to the incredible forces at work beneath. Scientists are now certain that Europa hides not just a subsurface sea, but a vast global ocean containing more than twice the volume of all the water on Earth. This entire world is an ice-covered water world, and the key to its liquid heart is Jupiter itself. The immense gravity of the giant planet constantly tugs and squeezes Europa in its orbit, a process called tidal heating. This gravitational kneading generates enough internal warmth to keep that colossal amount of water from freezing solid, creating a dark, salty sea dozens of miles deep, sealed under an ice crust perhaps 10 to 15 miles thick. The surface tells a story of this hidden ocean's activity. There are regions called chaos terrains, vast areas where the ice has broken apart into giant, jumbled blocks that look like icebergs frozen in place, suggesting the ice shell might be collapsing into or churning with the water below. Elsewhere, double ridges run for hundreds of miles, paired lines with a central groove, possibly formed by water from below repeatedly pushing up through cracks and refreezing. Every strange feature is a testament to the dynamic, likely habitable environment sealed underneath. To finally probe these secrets, NASA has built its most ambitious planetary mission in a generation, the Europa Clipper. This spacecraft will not land. Instead, it will perform dozens of close flybys using a powerful suite of instruments to essentially X-ray the Moon. It will measure the thickness of the ice shell, analyze the composition of the surface to look for organic materials that may have welled up from below, and even directly sample the tenuous atmosphere and any potential plumes to taste the ocean without ever touching down. Its core mission is to determine if this hidden abyss, with its life-giving water, chemical energy, and likely contact with a rocky seafloor, has the right conditions to support life. We are on the verge of answering whether our solar system holds not one, but multiple oceanic worlds, each a potential sanctuary in the cold dark. While Europa's hidden ocean churns in silent darkness, its neighbor presents a spectacle of pure, unbridled fury. Io is a world on fire, the most volcanically active body in our entire solar system. Forget the occasional eruptions of Earth. Io is a canvas of constant, violent creation, with hundreds of active volcanoes scouring its surface. This is not a landscape of ancient craters, for any impact scars are quickly buried under rivers of fresh lava and blankets of colorful sulfurous frost. Gigantic plumes of gas and dust shoot hundreds of miles into the thin sky, while lava fountains erupt with a ferocity that dwarfs anything on our planet, creating vast, simmering lakes of molten rock. The entire Moon is a dynamic hellscape, its surface constantly remade in real time. The source of this incredible violence is not internal radioactive heat, as on Earth, but the relentless gravitational tug of war between Jupiter and its other large moons, Europa and Ganymede. As Io orbits, the competing pulls of these massive bodies stretch and squeeze the Moon like a ball of clay, a process called tidal heating. This constant, intense friction generates colossal internal heat, enough to melt rock and power a global engine of volcanism. The result is a world where the very ground is unstable, where mountains taller than Everest rise and fall over geologic time, and where the primary surface colors are the brilliant yellows and oranges of sulfur compounds ejected from volcanic vents. Io stands as a stunning testament to the raw, transformative power of gravity, a world where the peaceful order of orbital mechanics translates into a permanent, surface-shattering inferno. The volcanic fury of Io shows a world constantly remade, but another moon presents a mystery frozen in time. Orbiting Saturn, Iapetus is a cosmic yin-yang symbol, a world of shocking contrast. One hemisphere gleams with the brightness of fresh snow, reflecting sunlight with stunning intensity. The other side is one of the darkest surfaces in the solar system, as black as asphalt, absorbing almost all the light that touches it. This stark divide creates a moon that seems to vanish when viewed from one angle and blaze into view from another, a celestial optical illusion. For centuries, the nature of this two-faced world baffled astronomers. The leading theory is a grimly elegant process of thermal migration. The dark material, possibly a layer of complex organic compounds, may have originated from outside Iapetus itself. Some scientists suggest it came from debris ejected by the distant, dark moon Phoebe, a captured outer moon of Saturn. This dark dust, spiraling inward over eons, would have coated the leading hemisphere of Iapetus as it plowed through the faint ring of particles. But here is the crucial twist. The dark area absorbs more sunlight, warming that side of the moon. This slight warming could cause any exposed water ice on the dark side to sublimate, turning directly from ice to vapor. That vapor then migrates across the surface and refreezes on the colder, brighter areas and poles, further cleaning the bright terrain and concentrating the darkness. It is a runaway process, a feedback loop that over billions of years painted one half of the moon black and left the other brilliantly white. Yet Iapetus holds a second, equally bizarre feature. Straddling its equator is a colossal ridge, a mountain chain that runs over 800 miles long and in places towers 12 miles high. From certain angles, it makes the moon look uncannily like a giant walnut or a cosmic sewing thimble. The origin of this equatorial ridge is just as puzzling. It could be the frozen remains of a ring system that once circled the moon and collapsed onto its surface, or perhaps the scar from a time when Iapetus spun much faster, causing its crust to buckle at the equator. Together, the two-tone face and the impossible ridge make Iapetus a unique sculptural oddity, a world that seems assembled from the spare parts of two completely different cosmic puzzles. From worlds of ice and fire, we turn to a planet undergoing a slow-motion collapse. Mercury, the sun-scorched innermost world, is not the static relic we once imagined. Instead, it is getting smaller. The evidence for this cosmic contraction is written across its entire surface in the form of colossal, cliff-like features called lobate scarps. These are not ordinary mountains. They are giant wrinkles hundreds of miles long and over a mile high in places, formed as the planet's interior cools down. Think of Mercury as a grape slowly turning into a raisin. As its massive iron core cools and solidifies, the entire planet contracts. The rigid outer crust has nowhere to go but to buckle and break, thrusting itself upward in these immense curved cliffs. The Messenger spacecraft mapped these scarps in stunning detail, revealing they are scattered globally and geologically young, meaning this shrinking is an ongoing process that has continued for billions of years and is likely still happening today. This discovery fundamentally changed our view of small, rocky worlds. We used to think that without the internal heat of a larger planet, places like Mercury would quickly become geologically dead, frozen in time after their formation. But Mercury tells a different story. Its slow, relentless contraction proves that planetary evolution never truly stops. Even a world baked by the sun is still dynamic, still changing, still writing its own history in the slow crumpling of its skin. It is a profound reminder that in our solar system, change is the only constant, playing out on timescales almost impossible for us to grasp. While Mercury slowly shrinks in on itself, its neighbor Venus presents a spectacle of atmospheric fury on a scale we are only beginning to comprehend. The surface of Venus is a hellscape of crushing pressure and lead-melting heat, but high above that inferno, in the planet's thick cloud decks, something impossible happens. The entire atmosphere is racing around the planet at a phenomenal speed, completing a full lap of the globe in just 4 Earth days. This phenomenon is called superrotation, and it means the winds at the cloud tops are whipping around Venus about 60 times faster than the planet itself rotates. Imagine a planet spinning so slowly that its day is longer than its year, yet its sky is a perpetual hurricane forever screaming around it. This creates a permanent, planet-wide jet stream of sulfuric acid clouds moving at over 200 miles per hour. The driving force behind this perpetual atmospheric sprint remains one of the great puzzles of planetary science. It is likely a complex combination of the planet's incredibly slow rotation and the way solar heat, absorbed in different layers of the atmosphere, sets up colossal circulation patterns that transfer momentum from the planet's surface all the way to the cloud tops. It is a global engine of weather with no off switch, a reminder that an atmosphere can have a life of its own, utterly divorced from the world spinning slowly beneath it. Yet within those hostile, acidic clouds, a recent discovery has ignited a firestorm of speculation. Astronomers detected traces of a gas called phosphine. On Earth, phosphine is a molecule almost exclusively associated with life, produced by microbes in oxygen-free environments like swamps or even in the intestines of animals. Finding it in the temperate, upper cloud layers of Venus, where pressures and temperatures are almost Earth-like, was a profound shock. It is important to stress this finding is hotly debated. Other scientists have questioned the data analysis, suggesting the signal might be from sulfur dioxide, a common volcanic gas on Venus, but if it is confirmed, the implications are staggering. It suggests the possibility, however slim, of a form of aerial life, not on the surface but floating high in the clouds, where tiny, extremophile microbes could theoretically exist within droplets of liquid, protected from the worst of the acid and heat below. This idea transforms Venus from a cautionary tale of a runaway greenhouse effect into something far more intriguing, a potential habitat in the most unexpected place. It forces us to ask, could life find a way not in oceans or on surfaces, but in the skies themselves, enduring in a perpetual storm of acid? The search for answers is driving a new wave of missions to our closest planetary neighbor, not to land on its deadly surface, but to sample and study those mysterious, super-rotating clouds, hunting for clues in the most unlikely corner of our solar system. The search for life can sometimes lead our own minds to play tricks on us, a truth perfectly illustrated by one of the most famous cosmic illusions of all time. In 1976, NASA Viking 1 orbiter was mapping the Cydonia region of Mars when it captured an image that would ignite the public imagination for decades. The black and white photo showed what appeared to be a colossal humanoid face, nearly 2 miles long, staring blankly up from the rusty plains. With its seemingly symmetrical eyes, nose, and mouth, it looked for all the world like a monument carved by some lost Martian civilization. The idea of a Martian sphinx captured headlines and fueled countless theories about ancient aliens and forgotten histories on the Red Planet. This powerful reaction, however, stems not from Martian engineering, but from a deeply human quirk of perception called pareidolia. This is our brain's innate tendency to impose familiar patterns, especially faces, onto random shapes and textures. We see the man in the moon, animals in clouds, and yes, faces in Martian rock formations. It is a survival mechanism, a way to quickly identify friend or foe in our environment, but it runs wild when confronted with the ambiguous landscapes of another world. The mystery of the face was not truly solved until decades later, when new generations of orbiters like Mars Global Surveyor and Mars Reconnaissance Orbiter arrived with far more powerful cameras. They flew over Cydonia again and again, capturing the formation in high resolution and under different lighting conditions. The definitive images revealed the truth. The so-called face was nothing more than a natural mesa, a butte heavily eroded by millions of years of Martian wind. The shadows that created the haunting facial features in the low-resolution Viking image were just that, shadows. From above, it was clearly a lumpy, cratered hill, a testament to geology, not artistry. This case became a classic lesson in scientific humility and the importance of better data. Yet, the allure of pareidolia on Mars persists. Enthusiasts scanning publicly available rover images have continued to discover all manner of familiar objects. A rock that looks like a crouching Bigfoot, another that resembles a perfect floating spoon, even formations dubbed Martian rats or thigh bones. Each time, closer inspection reveals a strangely shaped rock, a trick of light and angle, or the result of wind erosion. These illusions are not evidence of Martian life or activity, but they are evidence of something profound about us. They highlight our desperate, hopeful urge to find connection and familiarity in the vast, alien unknown. They remind us that exploring other worlds is a dialogue between what is actually there and what we, as humans, are hardwired to see. The real discovery here is not on Mars, but in understanding the filters through which we view the cosmos. The human mind may see faces in the rocks, but the true mysteries of Mars are written in shifting patterns of light and dark. Across steep crater walls and canyon slopes, especially in the planet's warmer mid-latitudes, spacecraft cameras have documented something strange and seasonal. When temperatures rise, dark, finger-like streaks emerge, stretching downhill for hundreds of feet before fading away as the cold returns. These are the recurring slope lineae, and their discovery sparked a firestorm of hope and debate. They looked for all the world like seeps, like damp patches where liquid water, perhaps just below the surface, was briefly trickling out to darken the soil before evaporating in the thin, cold air. The possibility was electrifying. If these were modern-day flows of liquid water, even if it was a super salty brine that could remain liquid at sub-zero temperatures, it would suggest that Mars was not a completely dead, dry world. It would mean that in certain places, under the right conditions, the most crucial ingredient for life as we know it might still be active on the surface today. This interpretation made these unassuming streaks some of the most tantalizing features in the entire solar system, potential oases in a global desert. But science thrives on questioning even the most exciting explanations. As researchers studied more and more of these recurring slope lineae with powerful instruments like the high-rise camera on the Mars Reconnaissance Orbiter, puzzles emerged. The streaks appeared on slopes that seemed too steep for liquid to cling to without pooling. Spectral analysis, which looks for the chemical fingerprints of water or salts in the reflected sunlight, repeatedly came up empty. No clear sign of hydrated minerals was found at the streak sites. This led to an alternative and perhaps more sobering hypothesis. What if the dark streaks are not wet at all? The newer theory suggests they could be entirely dry flows of granular material. Here is how it might work. On Mars, certain types of dark sand or dust may have a different texture or composition than the brighter surrounding soil. When the sun warms a steep slope, it could trigger tiny avalanches of this dark, granular material. The sand and dust cascade downhill, revealing a darker subsurface layer and creating the fleeting, streaky pattern. The seasonal timing could be explained by the way frost or subtle temperature changes alter the stability of the surface grains, not by the presence of liquid. This debate is far from settled. Some scientists still argue for a role for briny water, perhaps in amounts too small for our current instruments to detect from orbit. Others point to the dry flow model as the cleaner explanation. This ongoing investigation is a perfect example of how planetary science evolves. A stunning initial observation leads to a compelling story, one we desperately want to be true. Then, as more data rolls in, the story gets complicated, challenged, and refined. The recurring slope lineae teach us that Mars is a complex, active world, but its activity may not always be the kind we expect. Whether they are signs of hidden water or just the slow, granular sigh of a dusty planet, these mysterious streaks remind us that every new answer on another world simply leads to a deeper, more fascinating set of questions. Mars teases us with fleeting streaks that may or may not be water, but another world in our system presents a permanent and profound disorientation. Uranus does not spin like the other planets. It rolls. Imagine a top spinning perfectly upright, and then picture another top that has been knocked onto its side, spinning as it lies flat on a table. That is Uranus. Its rotational axis is tilted a staggering 98 degrees relative to its orbit around the Sun. In practical terms, this means the planet is essentially rolling around the solar system on its side. For a quarter of its 84-year orbit, one pole points directly at the Sun, bathing that entire hemisphere in constant daylight for a full 21-year summer, while the opposite pole is plunged into a 21-year winter of unbroken darkness. Then, as it continues its journey, the roles slowly reverse. This creates the most extreme seasons imaginable, a cycle of light and dark measured in decades, not months. The cause of this cosmic tumble is almost certainly a cataclysm from the solar system's violent youth. Most planetary scientists agree that a colossal impact with an object perhaps the size of Earth slammed into the young Uranus. This was not a glancing blow, but a world-shattering collision that literally knocked the planet onto its side. The force of such an impact would have been unimaginable, scattering debris, reshaping the planet's interior, and leaving it with this permanent, dizzying lean. This ancient violence also explains another of Uranus's bizarre features, its lopsided and chaotic magnetic field. On Earth, our magnetic field lines up roughly with our rotational axis, creating the north and south magnetic poles we are familiar with. But on Uranus, the magnetic field is a tangled mess. It is offset from the planet's center by nearly a third of the planet's radius and tilted at a wild 60-degree angle from its rotational axis. This means the magnetic poles are nowhere near the geographic poles. If you tried to use a compass on Uranus, it would point to a spot in empty space, far from the planet's actual north or south. This scrambled magnetic field is likely a frozen snapshot of the planetary interior in the aftermath of that giant impact, a turbulent dynamo of electrically conducting material that was thrown into disarray and never settled into an orderly pattern. So, Uranus presents a dual mystery, a world knocked askew by a primordial catastrophe, wearing the evidence not just in its sideways roll, but in the invisible, twisted magnetic forces that surround it, a permanent monument to the chaotic beginnings of our solar neighborhood. If Uranus wears the scars of a cosmic collision, the depths of both it and Neptune may hide a treasure born from that same crushing violence. Far below their swirling blue clouds of methane, in the immense inner layers of these ice giants, conditions become so extreme that chemistry itself twists into forms of breathtaking luxury. Scientists theorize that within the slushy mantles of these worlds, literal showers of diamonds may be falling. This is not science fiction, but a serious prediction based on the planet's bizarre composition and confirmed by remarkable experiments here on Earth. Unlike the rocky inner planets, Uranus and Neptune are classified as ice giants. Their thick atmospheres give way to a global ocean of supercritical fluid, a hot, dense mixture of water, ammonia, and methane ices under unimaginable pressure. It is within this churning, alien sea that the magic, or rather the extreme physics, happens. The intense pressure, millions of times greater than Earth's atmosphere at sea level, and temperatures reaching thousands of degrees, can tear apart the methane molecules. The carbon atoms, freed from their bonds, are then squeezed with such immense force that their atomic structure rearranges into the crystalline lattice of diamond. These newly formed diamonds, heavier than the surrounding fluid, would then begin to sink. Picture not a gentle glittering dust, but a relentless hail of diamond stones, perhaps as large as pebbles or even boulders, raining down through thousands of miles of strange, hot ocean toward the planet's rocky cores. For decades, this was a compelling but untested idea. Then, researchers found a way to bring a piece of an ice giant's heart into the laboratory. Using powerful lasers or devices called diamond anvil cells, they can take a sample of simple plastic, which contains the same hydrogen and carbon as methane, and subject it to a momentary flash of the same extreme pressures found deep inside Neptune. In these experiments, which last only billionths of a second, they have watched as the carbon within the sample compresses into tiny diamonds. We have literally cooked up diamond rain on Earth. This discovery does more than paint a surreal picture of alien weather. It reveals the truly exotic states of matter that are not just possible but probable under conditions far removed from our own experience. The interior of a planet becomes a vast alchemical forge where common elements are transmuted into precious minerals through brute force. It forces us to reconsider what wealth means on a cosmic scale. On a world like Neptune, a mountain of diamond would be just another type of rock, as common as granite is here. This theoretical downpour illustrates a profound truth about our solar system. The rules of physics are universal, but when you change the variables to such an extreme degree, the outcomes can feel like pure fantasy. The diamond rain theorized deep within Neptune is a hidden spectacle, but the planet's cloud tops stage a drama of their own. Neptune earns its title as the windiest planet in our solar system, with gales screaming at over 1,200 miles per hour, faster than the speed of sound here on Earth. Within this perpetual tempest, storms of staggering scale can appear and vanish with startling speed. In 1989, as the Voyager 2 spacecraft made its historic flyby, its cameras captured a colossal feature in Neptune's southern hemisphere. It was a vast, dark blue vortex, an anticyclonic storm large enough to swallow the entire Earth. Dubbed the Great Dark Spot, it looked eerily similar to Jupiter's famous Great Red Spot, a seemingly permanent fixture of the giant planet. But Neptune's spot was a different beast altogether. When the Hubble Space Telescope turned its gaze to Neptune just a few years later in the mid-1990s, eager astronomers were met with a shock. The Great Dark Spot was gone. It had completely vanished, leaving no trace in the southern hemisphere. This was no gradual fading, it was a disappearance. The storm, which had seemed so formidable and stable from Voyager's snapshot, had simply dissipated as if it had never been there at all. Yet Neptune's atmosphere refused to stay quiet. Hubble and later observations revealed that new dark spots would appear in different latitudes, some in the northern hemisphere, churning for a few years before they too faded away. These fleeting giants highlight the fundamental difference between Neptune and Jupiter. Jupiter's Great Red Spot is an ancient, deeply rooted storm, powered by the planet's immense internal heat and stabilized by its rapid rotation. Neptune, much farther from the Sun, generates its fierce weather primarily from internal heat left over from its formation, not from solar energy. This creates an atmosphere of profound turbulence where massive storm systems can erupt with ferocious power but lack the underlying stability to become permanent fixtures. They are like cosmic geysers of weather, bursting forth from the planet's deep energy reserves, raging across the blue expanse for a time, and then sinking back into the churning fluid from which they came. The lesson of the Great Dark Spot is one of cosmic impermanence. It reminds us that a single snapshot from a passing spacecraft captures just a moment in a planet's billion-year life. What looks like a permanent landmark from one visit can be a fleeting cloud by the next. Neptune's vanishing act teaches us to see the outer planets not as static portraits, but as dynamic, living worlds where the weather writes its story in storms that come and go with the seasons of a deep, internal clock we are only beginning to understand. Beyond the last known planets lies a frontier of ancient ice. The Kuiper Belt is a vast, donut-shaped disk of frozen remnants, stretching from the orbit of Neptune out into the profound darkness. This is the solar system's attic, a deep freeze preserving pristine building blocks from the dawn of our planetary system. For most of human history, we had no idea it was there. We saw Pluto, discovered in 1930, as a lonely oddball at the system's edge. It was only in the 1990s that astronomers began finding other worlds out there, revealing Pluto not as a solitary misfit, but as the king of a vast icy kingdom. We now know of thousands of these Kuiper Belt objects, with more discovered every year. Some, like Eris and Makemake, are nearly as large as Pluto itself, a discovery that ultimately led to Pluto's reclassification as a dwarf planet. These are not merely chunks of ice, they are time capsules, composed of rock, water ice, and frozen gases like methane and ammonia. They are the untouched leftovers from the solar system's construction, offering us a direct look at the original ingredients that eventually clumped together to form the giant planets. But as we mapped this distant realm, astronomers noticed something deeply puzzling. The Kuiper Belt does not simply fade away gently into the interstellar void. Instead, at about 50 times Earth's distance from the Sun, there is a sudden and dramatic cutoff. The number of detectable objects drops off a cliff. This boundary is known as the Kuiper Cliff, and its existence makes little sense according to our standard models of solar system formation. The primordial disk of material from which everything formed should have extended much farther out, thinning gradually. A sharp edge implies something swept the region clean, or that objects beyond that point were never formed in the first place. One of the most compelling and controversial explanations points to the gravitational influence of an unseen giant. Theoretically, a massive planet, several times the size of Earth, orbiting far beyond the Kuiper belt, could have shepherded the icy bodies within its reach, either clearing them out or herding them into unusual orbits that make them harder to detect. This hypothetical world is often called Planet 9, and its potential existence is inferred solely from the strange, clustered orbits of a handful of extremely distant objects that seem to be tugged by something immense. The Kuiper Cliff stands as a silent sentinel at the edge of our maps, a blank space on the celestial chart that whispers of a missing piece in our solar system's puzzle. Is it the ghostly signature of a true ninth planet waiting to be found, or evidence of a more ancient drama, like a passing star that stripped the outer belt away billions of years ago? The answer lies in the perpetual darkness, challenging us to question what we think we know about the very borders of our home. The Kuiper Cliff is not the only clue written in the ice. Far beyond it, astronomers have tracked a handful of objects moving in paths so strange they defy all conventional logic. These are the Sednoids, named after their first discovered member, the dwarf planet Sedna. Their orbits are not just distant, they are profoundly alien. Sedna, for example, travels on a lonely, elongated path that takes it from a point 76 times Earth's distance from the Sun at its closest approach, all the way out to a staggering 936 times that distance at its farthest, a journey that lasts over 11,000 years. Another, nicknamed Biden after its provisional designation 2012 VP113, follows a similarly stretched and distant track. What makes these orbits impossible to explain is their incredible isolation. At their closest points to the Sun, they are still far beyond the gravitational reach of Neptune. They never swing inward to interact with the giant planets that normally sculpt such extreme paths. According to everything we understand about orbital mechanics, these objects should not exist where they are. They are too far out to have been flung there by Neptune, yet their orbits are too tightly bound to the Sun to be true interstellar visitors captured from passing stars. They are celestial orphans trapped in a gravitational no-man's land. This profound paradox is the strongest fuel for the Planet 9 hypothesis. The leading theory suggests that a massive, undiscovered planet, perhaps 5 to 10 times the mass of Earth, orbits the Sun on a highly tilted path hundreds of times farther out than our own world. In this model, the gravitational influence of this hidden giant over billions of years has shepherded objects like Sedna and Biden into their peculiar, clustered orbits, like a hidden puppeteer arranging a cosmic dance in the dark. The Sednoids are the visible tremors caused by an unseen footstep. Their bizarre paths are not random. They share curious orbital similarities, their points of closest approach clustered in space and their orbits tilted in a similar direction. This clustering is statistically very unlikely to happen by chance. It is the pattern you would expect if a single, massive object were persistently tugging on them, organizing their long journeys. The hunt for Planet 9 is now a meticulous astronomical detective story, with teams scanning the deepest, darkest skies for a faint, slow-moving dot of reflected sunlight. Finding it would be a discovery of epochal proportions, rewriting the blueprint of our solar system. Until then, the lonely, looping journeys of the Sednoids remain as ghostly trails, pointing insistently toward a shadow in the outer dark, a reminder that the most profound discoveries often begin with something that simply does not belong. While the Sednoids trace ghostly orbits in the dark, another object closer to home presents a physical form of pure chaos. Saturn's moon Hyperion is a celestial accident, a world that defies every expectation of a solid body. It is not spherical, not even potato-shaped like many small moons. Instead, it resembles a gigantic, crumbling sponge tumbling through space. Its surface is a nightmarish landscape of deep, dark pits and razor-thin walls, giving it an appearance more like a fossilized wasp nest or a piece of cosmic coral than a planet's companion. This bizarre structure is not just skin-deep. Hyperion is mostly empty space, with a density barely half that of water. This 270-mile-wide object would float in a sufficiently large ocean. It is not a solid rock, but a loose pile of icy rubble held together by its own feeble gravity, a fragile aggregate of debris. The leading theory for its origin is as violent as its appearance is strange. Astronomers believe Hyperion is the surviving fragment of a much larger moon that was shattered in a cataclysmic collision billions of years ago. The debris from that impact mostly recoalesced, but Hyperion is the leftover rubble that never fully compacted, a permanent monument to that ancient smash-up. Its porosity means that when smaller objects strike it, they don't create typical craters with ejecta blankets. Instead, they punch straight into the soft, porous surface, compressing the material and creating those deep, dark pits with astonishingly sharp edges, further sculpting its sponge-like texture. This fragile form leads to its second great mystery, a completely chaotic rotation. Hyperion does not spin predictably like a top. Its rotation is tumbling and erratic, changing constantly due to the gravitational tug of Saturn and its larger moon Titan. Because of its irregular shape and porous structure, its motion is fundamentally unpredictable. You cannot point to where its north pole will be next month or even next week. It tumbles through its orbit like a drunkard, its orientation at the mercy of the forces acting upon its bizarre, spongy frame. In a solar system of spinning marbles and orbs, Hyperion is a tumbling, porous wreck, a world that is less a solid body and more a temporary gathering of ice and shadow, whispering of ancient violence and dancing to a rhythm only chaos can hear. Hyperion's chaotic tumble is a dance of ancient debris, but within the orderly asteroid belt, a dwarf planet hides a more serene form of alien geology. Ceres, the largest object between Mars and Jupiter, was long considered a simple, inert rock, a fossil from the solar system's dawn. Then, the Dawn spacecraft arrived in 2015 and transformed that dull rock into a world of gleaming mystery. Its cameras revealed something utterly unexpected scattered across the surface, brilliant, shining spots dazzlingly bright against the dark, rocky terrain. The most spectacular collection lies within the Ocata crater, a 57-mile-wide impact basin where a cluster of these bright deposits gleams like a celestial beacon. For months, scientists puzzled over their nature. Were they exposed ice? Could they be metallic reflections? The answer, when it came from Dawn's spectrometer, was both more exotic and more familiar. These are not ice or metal. They are vast deposits of sodium carbonate, a kind of salt. On Earth, we find such salts in places like dried lake beds, but on Ceres, they form brilliant, reflective crusts on the crater floor, the brightest material in the entire asteroid belt. The immediate question was how they got there. Sodium carbonate doesn't just appear on the surface. It had to be delivered, and the mechanism points to a world that is far from dead. The leading explanation is a process called cryovolcanism, or ice volcanism. Unlike the fiery, molten rock volcanoes of Earth or Io, cryovolcanoes erupt with a cold slurry of water, salts, and mud. Scientists believe that the impact that created Ocata crater millions of years ago fractured Ceres's crust, tapping into a deep, subsurface reservoir of briny water. This salty water, under pressure, then seeped up through the fractures. Upon reaching the airless, vacuum-like surface, the water would have instantly frozen into a haze of tiny ice crystals, while the dissolved salts within it were left behind as a bright, solid crust. Later, even after the initial eruption, more of this brine likely continued to ooze out in a slower, more persistent seep, building up those dazzling salt deposits over time. This discovery changes everything we thought about asteroids and dwarf planets. Ceres is not a static relic. It is a geologically active world with a subsurface layer of briny liquid, a relic ocean. It joins the ranks of Enceladus and Europa as another potential water world, though its ocean is likely locked in a thick layer of ice and rock. This means the asteroid belt, that zone of rubble we once saw as merely construction debris, contains a complex, differentiated world that underwent its own fascinating evolution. Ceres may have even been in the process of becoming a proper ocean moon or planet before the gravitational might of Jupiter stirred up the neighborhood, halting its growth. Those bright spots in Arcata crater are more than just a pretty mystery. They are the frozen tears of a hidden sea, a sign that even in the most seemingly barren places, the essential ingredients for life, liquid water and complex chemistry, can persist for billions of years, waiting in the dark to tell their story. Ceres gleams with the salt of a hidden ocean, but Jupiter commands an entourage of ancient shadows. Sharing the giant planet's orbit around the Sun are two immense swarms of asteroids known as the Trojans. These are not scattered randomly. Instead, they are locked in a cosmic balancing act, trapped in gravitational sweet spots precisely 60 degrees ahead of and behind Jupiter in its path. These locations are called Lagrange points, stable pockets where the pull of the Sun and the tug of Jupiter perfectly cancel each other out, creating parking places in space. The result is two vast clouds of primordial rock, one leading Jupiter in its orbit and one trailing it like a permanent celestial guard of honor. For billions of years, these objects have ridden this stable wave, never catching up to the planet and never falling behind, a testament to the precise mathematics of orbital mechanics. But the Trojans are more than just orbital curiosities. Their surfaces hold a visual clue to their incredible age. They are among the darkest and reddest objects in the solar system. This deep, ruddy hue is likely a coating of complex organic compounds called tholins, a tar-like substance created when simple ices like methane are bombarded by radiation over eons. This coloring suggests these asteroids are pristine time capsules, unchanged since the dawn of our planetary system, preserving the original chemical ingredients from the outer solar system's cooler regions. To unlock their secrets, NASA launched the Lucy mission, named for the famous fossil that revolutionized our understanding of human origins. Lucy's goal is equally revolutionary for planetary science. It is on a 12-year journey to visit no less than 8 of these Trojan asteroids, flying by objects in both the leading and trailing swarms. No spacecraft has ever visited these populations before. Lucy will give us our first close-up look at these ancient fossils, mapping their geology, analyzing their composition, and searching for organic materials on their surfaces. By comparing asteroids from both swarms, scientists hope to determine if they formed in the same region of the early solar system, or if Jupiter captured them from different parts of the protoplanetary disk. Each flyby will be a glimpse back in time, helping us piece together how the giant planets themselves formed and migrated, scattering material across the solar system in the process. The Trojan asteroids are a stable archive, a library of cosmic history written in dark red stone, and Lucy is finally turning the page. The Trojan asteroids are a stable library of our own solar system's past, but in recent years, our telescopes have captured pages torn from the libraries of distant stars. In October 2017, astronomers in Hawaii spotted a faint dot of light moving at impossible speed. Its trajectory was not a closed loop around the Sun. It was a hyperbola, a path with only one entrance and one exit. This was Oumuamua, the first confirmed interstellar visitor ever detected passing through our cosmic neighborhood. Its Hawaiian name means scout from the distant past, and it lived up to that title by presenting a cascade of mysteries. First was its shape. Based on how its brightness changed dramatically as it tumbled, scientists deduced it was profoundly elongated, perhaps 10 times longer than it was wide. This made it look less like a typical roundish asteroid and more like a cosmic cigar or a flattened pancake, a shape rarely seen in our own solar system. Then came the real puzzle, its motion. As Oumuamua sped away from the Sun, it accelerated slightly in a way that could not be explained by gravity alone. Something was giving it an extra push. For comets, such non-gravitational acceleration is common, caused by the Sun's heat vaporizing ices on their surface, creating a jet of gas that acts like a natural rocket engine. But Oumuamua showed no visible coma, no tail of gas and dust that telescopes could detect. It looked like a bare, inert rock, so what was pushing it? The debate exploded. Some scientists proposed it was a very unusual comet after all, one with a crust of organic material that sealed in its ices, allowing only a faint, invisible gas leak to provide the thrust. Others suggested it could be a shard of a Pluto-like dwarf planet, a chunk of solid nitrogen ice that was slowly evaporating in the sunlight, again without a visible plume. More exotic ideas, like a light sail of artificial origin, were considered and largely dismissed for lack of evidence, but they highlighted just how bizarre this object was. We had only weeks to observe it before it vanished into the dark, leaving a profound question hanging in its wake. 2 years later, the universe sent us a second, clearer answer. In August 2019, an amateur astronomer named Gennady Borisov spotted a new object on a similarly extreme interstellar path. This visitor, named 2I/Borisov, was immediately recognizable. It had a brilliant coma and a distinct dusty tail. It was unmistakably a comet, and a very active one at that. Analysis showed its composition was unlike most comets in our solar system, containing much more carbon monoxide, a clue that it formed in a different, colder environment around another star. Borisov's familiarity was its own revelation. It proved that Oumuamua was not a fluke and that interstellar visitors are likely common. More importantly, it showed the diversity of this cosmic debris. Our solar system does not just send comets and asteroids out into the galaxy, it receives them as well. These two scouts represent the first tangible pieces of other planetary systems ever to cross our threshold, silent messengers carrying the chemical fingerprints of alien suns. They force us to see our solar system not as an island, but as part of a vast, interconnected archipelago, where material has been exchanged between stars for billions of years, possibly even seeding worlds with the raw ingredients for life. Our nearest celestial neighbor holds secrets that flicker in the corner of our eye. For centuries, astronomers, both amateur and professional, have reported strange, fleeting events on the moon called transient lunar phenomena. These are not the slow, geological changes of eons, but sudden flashes of light, brief patches of color or haze, and momentary obscurations of surface features, all occurring on a timescale of seconds or minutes. The reports are numerous and persistent, dating back to before the telescope, with monks in the 12th century recording what they called a flaming torch on the dark limb of the moon. In the modern era, astronauts aboard Apollo 11 even radioed mission control about a bright area in the crater Aristarchus, asking if it was being illuminated from an unknown source. So what causes these ghostly flickers on a world we thought was geologically dead? Science offers several compelling, if incomplete, explanations. The most straightforward are meteorite impacts. The moon has no atmosphere to burn up incoming space rocks, so even a small pebble striking the surface at tens of thousands of miles per hour will explode in a flash of light visible from Earth. We have indeed recorded many such impacts during meteor showers. Another leading candidate is outgassing. The moon's interior may still hold pockets of trapped radioactive elements like radon. As these decay, they heat the surrounding rock, potentially causing a sudden release of gas that blows the fine lunar dust into a temporary, hazy cloud that can obscure the terrain below. Then there is a more subtle, otherworldly process, electrostatic dust levitation. The lunar surface, bathed in solar radiation and the solar wind, can build up powerful static charges, especially along the terminator line between day and night. This charge might suddenly lift ultra-fine dust particles off the ground, creating a faint, shimmering glow or a temporary mist above the soil. While these theories explain many events, a stubborn subset of reports defies easy categorization. They are the flashes that occur in places with no known gas vents, the glows that last too long for a simple impact, or the colored hazes that match no known dust composition. These anomalies keep the mystery alive. They remind us that for all our visits and rovers, the moon is not a static museum piece. It is a dynamic world where sunlight, radiation, and residual internal heat interact in ways we are still learning to see. The next time you look up at that familiar face, remember, it might just be winking at you. Jupiter's colossal magnetic grip extends far into space, but one of its captive worlds pushes back with a force of its own. Ganymede is not just Jupiter's largest moon, it is the largest moon in the entire solar system, bigger than the planet Mercury, and hidden beneath its icy, cratered shell lies a stunning secret, a churning, liquid iron core. This active metallic heart generates something no other moon possesses, its own intrinsic magnetic field. This makes Ganymede a miniature planet in its own right, a world with a hidden dynamo. The result is a cosmic nesting doll of magnetic forces. Ganymede's small, self-generated magnetosphere is embedded directly within the overpowering magnetic bubble of Jupiter itself. Picture a tiny, independent force field trying to hold its shape inside a hurricane. This creates a zone of incredibly complex physics where the two magnetic fields clash, merge, and tangle. One of the most visible and beautiful consequences of this struggle is auroras. Just like Earth's northern lights, charged particles from the Sun and from Jupiter's own radiation belts spiral along magnetic field lines and slam into the thin atmosphere at Ganymede's poles. But because the magnetic geometry is so twisted by Jupiter's influence, these auroras do not form neat rings. Instead, they are shimmering, chaotic ovals that rock and sway with the moon's orbit, a luminous dance dictated by the tug-of-war between two cosmic magnets. This magnetic personality tells us something profound about Ganymede's interior and history. For a moon to have a global magnetic field generated today, it must have a source of internal heat keeping part of its core molten and in motion. The leading theory points again to tidal heating. As Ganymede orbits Jupiter, gravitational interactions with its sister moons Europa and Io flex its interior, generating enough warmth to keep that iron core liquid and churning, powering the dynamo. This reveals Ganymede as a world of surprising internal complexity, likely structured in layers like a cosmic onion, a metallic core, a rocky mantle, a vast global ocean of salty water, and finally a thick outer shell of ice. That subsurface ocean, sandwiched between layers of ice and rock, is another potential habitat, another hidden sea kept liquid by the same forces that stir its metallic heart. Ganymede is far more than a frozen ball of ice. It is a dynamic, layered world with a hidden ocean, a molten metal core, and its own magnetic signature fighting for independence within the domain of a giant. It is a reminder that even satellites can have the sophisticated inner workings of a planet. But those dark, alien seas on Titan are not simply pools of liquid methane. Some of them hold a texture as bizarre as their very existence. Radar data from the Cassini spacecraft, bouncing signals off Titan's surface, revealed a startling fact about the lakes clustered at the moon's north pole. Their surfaces are unnervingly smooth, as flat and reflective as a pane of dark glass. On a world with an atmosphere, even a slight breeze would create ripples. The fact that radar saw perfect mirrors means these lakes are often eerily calm, their surfaces as still as a sheltered pond on a windless night. This smoothness hints at the liquid's thick, syrupy nature. While methane is a key component, analysis suggests these polar lakes are richer in a heavier hydrocarbon, ethane. Mixed with dissolved nitrogen and a soup of other organic compounds that rain from the orange haze, the result is not a thin, runny fluid. It is likely a viscous, sticky brew, with a consistency closer to cold tar or liquid asphalt than to water. Imagine a vast, black lake of slowly churning petroleum, its surface so flat it perfectly reflects the hazy, eternal twilight of the Titanian sky. This strange composition sculpts the shorelines into forms that would puzzle any Earth geologist. Some coastlines appear sharply defined, like the edge of a black lacquer spill, suggesting the thick liquid is slowly dissolving the icy bedrock. Others show evidence of what might be ancient, dried-up lake beds, now vast plains of organic sediment. In a few places, radar suggests the lakes may have porous, sponge-like borders, where the dark liquid has seeped into the ground, creating a sodden hydrocarbon marsh. This is a landscape where the very ground can be both solid and saturated, a frozen slush of water ice soaked with sticky organic goo. And within these stagnant, asphalt-like pools, a profound chemical experiment is underway. The constant drizzle of complex organic molecules from the sky, combined with the energy from Saturn's radiation and perhaps even weak tidal forces, could be cooking up increasingly complex chemistry in the dark. These lakes are not just geological features, they are vast, cold, probiotic laboratories. They concentrate the building blocks of life, carbon, hydrogen, nitrogen, in a solvent that is utterly alien to us. While the thick, cold sludge is hostile to life as we know it, it forces us to wonder what novel forms of chemistry, what first steps toward complexity, might be possible given millions of years of quiet, dark stewing. What kind of molecules could form in a lake that never sees the sun, where the main ingredient is liquid natural gas as thick as pitch? Titan's asphalt seas are more than just a curiosity. They are a challenge to our very definition of a habitable environment, proving that the recipe for complexity can be written in the most unexpected and unsettling of inks. This unpredictable tumble is not a gentle wobble, but a state of pure mathematical chaos. Hyperion's rotation is so profoundly disordered that astronomers cannot calculate its future orientation with any certainty. Unlike Earth's reliable 24-hour spin or even the slow, predictable rolls of other moons, Hyperion has no set day. Its irregular, potato-like shape is the key to this pandemonium. Because its mass is not distributed evenly, the gravitational pulls from Saturn and its massive neighbor Titan do not act on a symmetrical body. They tug harder on the moon's protruding parts, imparting uneven torques that constantly knock its spin off balance. Think of it not as a top spinning on a table, but as a lopsided rock tossed erratically through the air, tumbling end over end with no repeating pattern. One month, its long axis might point toward Saturn. Weeks later, it could be spinning almost perpendicular to its orbit. This makes Hyperion one of the very few confirmed chaotically rotating bodies in our entire solar system, a true celestial oddball dancing to a rhythm only chaos can compose. This profound instability offers a glimpse into a past of violence. Most moons are tidally locked, meaning one face forever points at their planet, a state achieved after eons of gravitational smoothing. Hyperion's chaotic spin suggests it escaped this fate. Its porous, fragile structure and distant orbit likely prevented the tidal forces from Saturn from ever breaking its rotation into a predictable lock. Instead, it remains a frozen snapshot of disorder, a permanent relic of the dynamical chaos that ruled the early solar system. To stand on its spongy surface would be an experience of profound disorientation, with the colossal ringed arc of Saturn swooping and whirling across the sky in an unpredictable loop, daylight and darkness arriving at random intervals. In a cosmos often governed by elegant orbital clocks, Hyperion is a reminder that chaos, too, has a permanent place in the celestial machinery, tumbling through the dark as a monument to instability. While Hyperion tumbles in chaotic disorder, another asteroid holds a form of order so profound it could rewrite our understanding of planetary birth. Deep within the main asteroid belt, orbiting between Mars and Jupiter, lies a world named 16 Psyche. It is the target of an ambitious NASA, a mission launching this very year, and for a reason that has nothing to do with its lumpy, potato-like shape. Scientists are not traveling there to see another cratered rock. They are going because they believe Psyche is something humanity has never seen before, a world made not of stone or ice, but of gleaming, elemental metal. The evidence comes from how it interacts with light and radar. When astronomers study the sunlight reflecting off Psyche, its spectrum is dark and largely featureless, lacking the telltale chemical fingerprints of rocky minerals or water ice. More compellingly, radar signals bounced off its surface show an astonishingly high reflectivity, a metallic shine that is off the charts compared to typical asteroids. Its density, calculated from its gravitational influence, is also incredibly high for its size. All these clues point to one staggering conclusion: 16 Psyche is likely the exposed, naked core of a failed planet. In the violent dawn of our solar system, a protoplanet the size of Mars may have been forming, with its interior differentiating into layers. A dense metallic core sinking to the center, surrounded by a mantle of silicate rock. Then, in a cataclysmic series of collisions, the rocky mantle was brutally stripped away, blasted into space, leaving behind only the battered metallic heart. This makes Psyche a singular archaeological treasure. It is a time capsule offering a direct, unadulterated view into the secret centers of rocky worlds like Earth, Mercury, or Mars. Places whose metallic cores are forever hidden beneath thousands of miles of rock. We have never touched a planetary core. We can only infer what ours is like from seismic waves and magnetic fields. At Psyche, we could walk on one. The composition is theorized to be primarily iron and nickel, the same metals that make up Earth's own core. But within that mix, in the high-pressure crucible of a forming world, other precious metals like gold, platinum, and iridium would have also sunk to the center. This leads to the eye-popping, if theoretical, speculation about its material worth. Based on current metal prices and estimates of its mass, the raw material value of Psyche has been calculated in the quadrillions of dollars, a number so vast it becomes meaningless. It is a literal floating mountain of cosmic bling. Of course, mining it is pure science fiction for countless practical reasons, but that staggering figure underscores its utterly alien nature. The upcoming Psyche spacecraft will spend nearly 2 years orbiting this metal world, mapping its topography, analyzing its composition, and measuring its residual magnetic field to confirm its origin story. Is its surface a solidified sea of iron, scarred by metallic volcanoes? Are there strange, towering cliffs of nickel-iron alloy? Does it hold the magnetic ghost of a dynamo that died billions of years ago? Every answer will be a revelation, a page torn from the very first chapter of our solar system's history. This mission is not about resource extraction. It is about cosmic archaeology, journeying to a place that is less a world and more a fossil, the gleaming metallic skeleton of a planet that never was. The final entry in our catalog is not a discovery we can photograph, but a shadow we can feel. It is the persistent, haunting possibility of a true giant lurking in the solar system's darkest reaches, a world we call Planet 9. This is not speculation born from a blurry image, but from the cold, hard mathematics of orbital mechanics. The evidence is written in the paths of the most distant objects we know, the sednoids like Sedna and Biden. Their clustered, tilted, and impossibly stretched orbits are not random. They look precisely like the signature of a massive gravitational shepherd, an unseen hand persistently tugging on these icy wanderers over billions of years. To create that pattern, astronomers calculate the hidden world must be colossal, perhaps 5 to 10 times the mass of Earth, orbiting the Sun on a wildly elongated path hundreds of times farther out than our own planet, taking 10,000 to 20,000 years to complete a single journey around the Sun. This would make it the true ninth planet, a frozen super-Earth in a realm of perpetual twilight. The hunt for this ghost world is a monumental challenge. At such a distance, it reflects only the faintest whisper of sunlight, and its motion against the backdrop of stars would be agonizingly slow. Astronomers are using the world's most powerful telescopes to scan the likely slices of sky where it could be hiding, comparing images taken months or years apart to spot one faint dot that has moved just a fraction. It is a needle in a haystack search on a cosmic scale. If it is found, the questions will be as profound as the discovery itself. Where did Planet 9 come from? Is it a primordial giant that formed in the outer disk and was flung into its strange orbit by a gravitational dance with Jupiter or Saturn in the early chaos? Or is it something even more extraordinary, a rogue exoplanet captured from another star system as it drifted through our galactic neighborhood? Its existence would force a complete rewrite of our solar system's origin story. It would explain the peculiar tilt of the Sun, the strange orbits of distant objects, and the very architecture of the Kuiper Belt's edge. It would mean our family portrait has always been missing its most reclusive member, a titan of ice and rock silently governing the frontier from the dark. Until a telescope catches its glint, Planet 9 remains the ultimate solar system mystery, a gravitational phantom whose presence is felt in the trembling paths of distant ice, a reminder that the greatest discoveries often begin not with a seen light but with an unseen pull. From ghostly planets to diamond rain and methane seas, this journey reveals a solar system far stranger than any science fiction. We have wandered past worlds that roll on their sides, moons that spray their oceans into space, and asteroids that are the metallic hearts of shattered protoplanets. These 25 bizarre discoveries are not mere curiosities. They are fundamental challenges, each one a crack in the facade of a simple, orderly solar system. They prove our cosmic backyard is not a static museum of known facts, but a living, breathing, and profoundly weird laboratory where the rules of nature are constantly being rewritten in ice, fire, and metal. Every unexplained hexagon, every vanishing storm, every tumbling rubble pile is a question waiting for an answer, and that is what drives exploration forward. It is why we build spacecraft like Europa Clipper and Dragonfly, why we hunt for Planet 9 in the deep dark, and why we keep training our telescopes on these familiar yet alien worlds. The pursuit of these mysteries is a celebration of human curiosity, a testament to our refusal to accept that we have everything figured out. So as you look up at the night sky tonight, remember the incredible diversity hiding in plain sight. Which of these cosmic secrets captured your imagination the most? Let us know in the comments below. If you enjoyed this tour of the wonderfully bizarre, be sure to subscribe for more journeys into the mysteries of space. Keep looking up and never stop wondering about the strange and magnificent neighborhood we call home.